Alright, so this section is over independent and dependent. So let's start off with the definition of independent and dependent. Independent is a variable that's value determines the value of an output. Now, we generally call this independent variable our x because that's usually what it is, but it's whatever letter is inside the equation that we're talking about. And the output is usually the y, or whatever we're equaling, whatever's on the other side of the equal sign. The dependent, it's a variable that depends on the value of the input. Now, generally we think of the dependent variable as the y, and the input, remember, is usually our x. So the dependent depends on something else for value. I don't know what the dependent is until I can do some calculations and I know what the independent is. So let's look at some examples. It says identify the independent and dependent variables. The first one says Jake works as a sales representative. He earns $1,275 per month plus an 8% commission on his sales. So I like to start with the dependent. What am I trying to figure out? If I'm talking about money and I'm talking about his sales, what am I trying to figure out? Well, I'm trying to figure out his total pay, what he's totally going to get paid after each month and his commission. Then I look at the independent. Well, what is the independent? He's going to earn the $1,275 per month no matter what, but he has an 8% commission on his sales. So I don't know what the total pay is until I know the amount of his sales. If he only does $100 in sales, his commission is going to be smaller. Versus if he does $5,000 on his sales, his commission is going to be bigger, so he's going to make more total pay. So the total pay depends on the number of sales he makes. Fewer sales, smaller pay. More sales, more pay. Let's look at another example. The number of gumballs G that can be packaged in a box with the volume of V cubic units is given by the equation G is equal to 40V plus 15. So if I'm looking for the independent variable, I'm looking for what's inside the equation. Independent, inside the equation. So that letter would be V. And I know that V stands for the volume of the box that I'm talking about. So then the dependent would be the G, the gumballs, because the number of gumballs depends on what the volume of the box is in this formula. So dependent would be G, the number of gumballs, because the number of gumballs depends on what the volume of the box is. Alright, let's look at some that deal a little bit with numbers. It says identify a number that is a value for the independent variable but not the dependent variable. So it says the following points represents the ordered pairs of a function: 2, 4, 3, 2, 4, 3, and 5, 13. So I kind of set it up to where we can answer the question. To figure out which one's an independent but not a dependent, I first want to know what are the independent variables, what are the dependent variables, and what does the independent have that the dependent doesn't. So if I'm looking at independent variables, I'm looking at my x values, or the first number, the inputs. So these would be my independent variables. So 2, 3, 4, and 5. Those would be my independent. My dependent would be these y values. And in this case, it's 2, 3, 4, and 13. And I just listed them in numerical order. So I'm looking for a number that's an independent but not a dependent. So 2 is an independent, but it's also a dependent. 3 is an independent, but it's also a dependent. 4 is an independent, but it's also a dependent. 5 is an independent, but it's not a dependent. So 5 would be my independent that's not a dependent. So let's look at the next one. Independent but not a dependent. So remember, independent's usually my x values and dependent's usually my y values. So these are my x numbers and these are my y numbers. So when I'm looking at the independent, I'm looking at these numbers down here. Well, there's a dot up here at 1. So 1, and then there's a dot on the 2, and there's another one on the 4. There's not one again until 7, and then 1 and 8. Now I'm going to look at the dependent. So I'm looking at these numbers right here. So on the 1, there's a dot all the way over here. On the 2, there's a dot. Then there's not another dot again until 6, and then 7, and then 8. So which one is an independent but not a dependent? Well, 1 is independent, but it's also dependent. 2 is independent, but it's also dependent. 4 is independent, but I don't see a dependent 4 down here. 7 is independent, but it's also dependent. 8 is independent, but it's also dependent. So it says is an independent, but not a dependent. So that number would be 4.